Hello, YouTube. This is UMills03. In the previous lesson, we introduced the concept of object-oriented programming, which is essentially what basically the rest of our curriculum will be focused on. Okay, so the goal is to create our own data types. We already know that we can create ints and strings and lists, but what if we wanted to create person objects or dog objects or car objects, right? And we found that there were properties and functions that were important, that were intrinsic to those objects. And we want to be able to have that kind of functionality. So for example, for a person object, if we sent a person to work, we would want basically the value of some variable called income to increase, because presumably income would be a variable that a person object would be keeping track of. So that's an example of sort of where we're going. Is the goal is to create our own blueprints, which are going to have, number one, they're going to have variables or data or specific points of information, like a person's name or a car's model, but they're also going to have functions. They're also going to have functionality, more verbs, things that they do, things that they return, values that they change, things that they print, so we're going to be seeing examples of both of those, both fields and functions for a particular class. And in the previous lesson, we talked about a person class, okay? And so what we did is we talked about, basically, we defined a person class down here. So we have class person. And we said that any class can have class variables. So these are variables that pertain to the class in general. Okay, so we would say a general person can speak, but a general person cannot fly. Okay, so these are variables that are intrinsic to the class as a whole, rather than to a particular specific instance of the class. Now, if they're true for the general person, they will also be true for the instances, unless one of the instances changes the value of their instance variable. So an instance could change the value of one of these variables, but only for that particular instance. But we're going to talk about that. But you have to remember, a class is like a blueprint, and an instance is an example. It's an example object. Okay, so you and I are instances. Okay, but we both belong to the person class. Okay, and a constructor is a special type of function that creates an object by assigning the object's important instance variables, the important variables, to particular values that the user specifies when he or she is creating the instance. So that's what we saw in the previous video, right? So if we say self dot and then the variable name, we're referring to an instance variable. So this is indicating to Python that name and age are not going to be part of a general person, but they're going to apply specifically to instances. Okay, every person will have a different name and age, and we wouldn't say that a general person has a default name or age. We would just assign specific values depending on the instance we were talking about. So we could have an instance with a 22-year-old named Pete, or we could have another instance with a 39-year-old named Tori. So hopefully that's clear to you. And then the values of these instance variables would be assigned to different things, because there were different inputs to the constructor for each of these constructor calls. So hopefully that's clear to you. And then we also have doc strings, okay? A class can have variables initialized at the top. We saw the can speak, the can fly. Those both happen to be Boolean variables. Then we had an income variable, which was an integer. The class itself has access to these class variables, as well as any instances of the class that were created. So at this point, you could either print person.canSpeak and just figure out the value of that class variable for a general person, or you could print w.canSpeak, right? You could figure out the value of the canSpeak variable for this instance in particular, okay? And there might be a difference between the value of an instance variable and the value of the class variable, and we're going to see an example of that in a second. We're going to talk about the work function, which we saw in the previous video, and that would allow a particular instance variable to increase its value by 10,000, but the class income, the class variable income, will still stay at 0. Okay, so can speak and can fly are class variables rather than instance variables. They apply to person objects in general, and their values cannot be changed for a particular instance of the person class. Okay, it would be okay. So then you would have to go ahead and you would actually be able to change their values. Okay, so their values can be changed for a particular instance, but if you're talking about person objects in general, then those values will stay as they were declared at the top of the class. So hopefully that makes sense to you. Okay, so then what you could do, the same applies to the income variable, right? And so it doesn't, so I think the reason why I said that these values cannot be changed, I mean, theoretically they could. Theoretically, if you had a function to make someone fly, you could just switch the can fly variable. You would say self.canFly equals true, and that would change the instance variable, but not the general can fly class variable, okay? But the reason why I said cannot is just because I don't have that implementation, right? But what I did implement is a work function, and I'm saying that the work function can change an instance variable without changing the class variable. So if we scroll down here, we see a work function. So work of self. And remember, this is not an input, but every time we're talking about an instance, right? If you're talking about a constructor, you're creating an instance. If you're talking about working, you know, a particular instance is working. If you're talking about getting someone's birth year, that applies to a particular instance. So that's why you have to have self as basically the first argument into all these. You just write self. Okay, and then self.income, that means that you're referring to the particular instance variable's value of income. Okay, when you created the instance variable, it took the class variable's value of 0, but now the particular instance can increment its value of the variable without changing the general value of income for the person class. Okay, and so this is an example of an instance void method. It's instance because it pertains to a particular instance, and it's void because it does things, but it doesn't return anything. Get birth year is a return instance method. So this returns a number, and we need to call it on a particular instance because age is intrinsic to an instance. That's why it says self.age, right? It wouldn't just be an age of some person. It would be a particular person, a particular instance's age. That's why it says if you hover over it, instance attribute age of the person class. So hopefully that makes sense to you. And we tried some of those things out. So this code is from one we ran previously, right? So my name is Sam, right? X.name here would be Sam because when we did that constructor call, we assigned name to Sam. And then we can also have I am, and then we had to convert the int to a string here. So that's why you say I am 22 years old, right? But the age variable would be different depending on the instance. So if you have a different instance of the person class, there will be a different value for the instance variable. Okay, x.can speak, it would take the person's value of can speak, which was true, so we print I can speak. But for x.can fly, it would take the general person's value of can fly, which is false, and that's why we say I cannot fly. We can also create some other instances, so just y equals person of Jake and 32, z equals person of Abby and 45, z2 equals person of Troy and 26. We can also put them into a tuple. So we said we can have a tuple of tuples, we can have a tuple of floats, we can have a tuple of strings, we can have a tuple of dictionaries, but we can have a tuple of objects just like we can have a tuple of ints or a tuple of tuples, right? So this is just, you know, each of the elements in the tuple is a person object. So hopefully that's clear to you. It's just referencing these different person objects, right? And so then what we're going to do is we're going to go ahead and try to print the value of the income class variable. And we know that that's going to be 0 just in general. So then if we go ahead and run it, then we get 0 on the bottom, right? Because at the beginning of the class definition, we said that the income was 0. But now what we're going to do is we're going to say for each of the person objects in the tuple of person objects. So for I and my tuple, this is pretty straightforward notation, right? Well, we're going to call the instance void method work. Okay, so remember, a void method doesn't return anything, it just does something. Okay, and this is going to apply to a particular instance, which means that we need to go ahead and apply it to a particular instance. So that's why this is a class variable. So we said person.income. But if you're talking about an instance variable or an instance function, you would say I.work rather than just person.work, because I refers to an instance and work is an instance method. So all 4 of these person objects are going to go to work, and they're going to do whatever's in the work function. So they're going to basically say, I need to go to work, and then the value of their particular income variable is going to go up by 10,000, right? And then what we're going to do is we're going to say y equals 0, while true, if y is equal to the length of my tuple, break. Okay, so obviously you can see that this architecture, I mean, you can probably imply at this point that this is going to iterate through my tuple, right, with a while loop, and you're going to say print my name is, and then whatever the name instance variable is for that particular person object. And now I have, and then a $sign, and then the string representation of the value of the income instance variable for that particular instance. So now let's go ahead and run it, and we can see the value of the income instance variable. So all 4 of them worked once, and so they all have $10,000, right? What if we had all sent them to work twice? What if we had edited this code to say I.work twice, right? So now they have to say 2 things all. They all say 2 things, right? So we're going to have 8 work statements because there were 4 person objects, each of whom were working twice, and now they're all going to have $20,000, right? But then if we go ahead and print the value of person.income, we can say, but a general person object would have, and then we can figure out the value of the class variable. So now if we go ahead and run it, it's still $0. So hopefully that makes sense to you, and those are the fundamentals of object-oriented programming. What we're also going to talk about in this video is inheritance. Okay, we're going to talk about something called inheritance. Okay, so basically we can have inheritance. Okay, basically a subclass can inherit a superclass. This means that a subclass can extend all of the functionality, can receive all of the class variables and functions from the superclass. So for example, consider a general person class, and we will create a student subclass. So the student class will have all functionality from the person class. So for example, we will use the same constructor to create student objects as we did to create person objects. So you could go ahead and say something like, Q equals student, okay, and then you could say something like of Sam and 12, okay, or something like that. But it would be using the person's constructor if the student is going to inherit person, okay, and this is how you would denote that. You would say class student of person, okay, it's kind of like a function notation, but this means that student class is declared, and it will start by inheriting everything in person. Okay, so it's a way of basically taking a more general superclass and extending it, coming up with a more specific example. Okay, a student would be able to do everything that a person can do, but a person might not be able to do everything that a student can do, right? Maybe there are specific variables that we would want to keep track of with a student, right? So then maybe we could keep track of their GPA, right? We could keep track of their GPA or something like that. And then we would want to go ahead and assign that somewhere, right? But then, you know, these would be other variables, right? So then this is what's going on here. So this is an example of a subclass, right? Okay, and then there can be multiple subclasses for the same superclass. So you could have also had a doctor of person. Okay, so doctor would takes all of person's functionality, and then is able to create or redefine it however it wants. So essentially, when we have a subclass that inherits a superclass, you can take as much of the superclass's functionality that you want. You can take all of it and then add nothing on, right? And then it would behave the exact same way. You can take all of it and then you can add on your new stuff, right? So it would just function the same way, but then you would have more opportunities, more functions available to you. You could take all of it, but then you could modify some of it, right? You could take the work method from person. If you were in the student class, right, you could inherit person's work method, but then maybe you could come up with a slightly more specific work method if you were talking about a student in particular. Okay, so what we can do is subclasses can use all of superclasses functionality, okay, but they can also come up with their own variables and functions, or they can redefine variables and functions which were already initialized or referenced in the superclass. So we're going to see some examples of that. So now let's take a look at the definition of this student subclass. We have an income variable. We have a class variable for this subclass, and its income equals 20,000. But I thought there was already an income variable in the superclass. So if we go ahead and scroll up, we already have an income variable with a value of 0. But what this does, this is called overriding the value of a class variable. So for the student class, income is 20,000, not 0. Okay, so this is basically called overriding the value of a class variable, and that's totally okay. If you had not written this, basically, without writing line 234, income equals 0 by default, as this value is inherited from the person superclass. So hopefully that's clear to you. And then we can also go ahead and redefine work. Okay, so remember, self is not an input here. Self means that we're referring to a particular instance of the student class, a particular student. Okay, and so what we have is super.work. So what this does is super.f basically calls the functionality of the superclass's definition of f. Okay, so here we will use person's work function first. Okay, it's just going to basically implement the functionality from the superclass. Okay, and then if you had said something like super.f of 2, this would basically call the superclass's version of f with an input of 2. Okay, so that would be if you were talking about a function that accepts an input But this is an example of a function that doesn't accept an input. Remember, self looks like an input, but it's not. It's just basically a keyword to Python that we're referring to an instance, right? But the work method up here, if you go up to the work method up here, it doesn't accept any inputs. You just remember when we tried running the work method on particular instances of the person class, we just said i.work, right? You don't have to accept anything. It doesn't even, in order for a person to work, you don't have to feed it any other information, right? It would just have an income variable and it would know the value of it, and it would just increment it by 10,000 and print, I need to go to work. But what we're going to do is we're going to take the superclasses functionality of the work method, and we're going to basically extend it. So we're going to take everything that's in the superclasses work function, and we're going to add on, we're going to print, I cannot be late for my work study. So now instead of just printing, I have to go to work now, I need to go to work now, it's going to, I need to go to work now and increment income by 10,000, because that's what we told it to do in person's definition of work. And now if we're talking about a student working, they also are going to say, I cannot be late for my work study. So this is basically an overridden work function, which uses the superclasses version, but also extends it. Okay, it also adds on a little bit of its own code. Okay, we do not need, okay, so now what we do is, what about this get birth here? Okay, so now if we do not do anything with get birth here, as it was defined in person, then it works the same way for students. And then we can also come up with our own methods, right? So we can just say fun function, okay? We can just say fun function, okay, of self, and we can call it on a particular instance, right? We can call it on a particular instance, right? So then we could go ahead and say something like print, let's say self.name. Okay, it's just going to print, let's say the length of their name, So it's going to be an instance method. We need to call it on a particular student. Okay, but this function belongs to the student subclass, but not the person superclass. Okay, so student objects can call this function, but not general person objects. Okay, so we're going to see an example of that. So what we're going to do, we're going to try creating an example of a subclass, and we already talked about all this code and ran it, so I'm just going to go ahead and delete it, and feel free to rewind if you need to. But what we're going to do is we're basically going to say something like x equals student of, and then we could say something like Tori and 22. Okay, so now we're talking about a student object, but it uses person's constructor to assign name and age to Tori and 22. Okay, so that is just inherited from person. It's functionality that the subclass has available to it. But now what we're going to do is we're going to go ahead and say print of x.income. Okay, and now instead of seeing 0, we should see 20,000 here, because we said right off the bat, the student class, the value of the income variable for student is 20,000, right? And then what we're going to do is we're going to send her to work. And then what we could go ahead and do is figure out what her income is going to be after that. And it's going to use, remember, it uses the superclasses work function and then just prints as one other thing. So we're still going to be incrementing by 10,000. We're still going to say I need to go to work now. The only difference is we're also going to print one more thing. I cannot be late for my work study. So hopefully that makes sense to you. And then we could also call the x.fun function, right? And so this would be totally legitimate too. And it would probably print 4, right? Because the length of Tori is 4, okay? But if you tried printing a person object, if you just did a regular person, Philip and 81, and you said y.fun function, you can predict that there might be an issue with this, right? It already highlights it, it gives us a warning, and it says unresolved attribute reference. So fun function is accessible to student objects in particular, but not to person objects in general. Okay, but work function, but the other functions that were in person, student can use them. Okay, so you could have also said print of x.getBirth here, right? Because that was literally just inherited from person. We didn't do anything with that up in student, but that's just because student takes person's implementation of that. So now we can go ahead and run it, and let's go ahead and make sure that this works as it should. Okay, so now what we can do, let's take a look here. So this is from a previous example. That's when we were looking at the itertool stuff. So we have 20,000. That's what we were expecting for the value of that class variable, right? And then she worked, so Tori worked, and so I need to go to work now. I cannot be late for my work study. And then remember, in that function, it also increments 10,000 because that's what it did in person's implementation, which student inherited and built on. Okay, and then income goes up to 30,000. and then we get 4 for the length, and then we get the birth year of 1999 because 2021 minus 22 is 1999. So hopefully that's interesting. We'll continue in the next video. That's called inheritance. From UMills03, thanks for watching, and please subscribe.